Hi scholars, so today our learning intention is thoughtful mathematicians represent whole number fractions on a number line. Sorry, the smart is a little delayed. So we're representing whole number fractions on a number line. So today we're focusing on fractions greater than 1 because a whole number fraction is in fact a fraction greater than 1 or an improper fraction. For example, if every box I draw represents one whole, right, and I'll draw a separate one up here. So these are all one wholes. This specific fraction is going to be different from this one, and I'll explain why now. So I've broken these parts apart. I'm going to shade in two of them. This is 2/4, right? These are two separate wholes, and I have not shaded anything. I have not broken anything down. Actually, I'm going to shade them in, but I'm not going to break them apart. I'm just going to shade both of them in entirely. So I have two entire wholes that I shaded in. But I want to write this as a fraction. How do I do that? My numerator is going to be 2 because that's the number of pieces I have. But I have two what? What are the parts? So I'm going to write 1 because they're both wholes. They're one whole. So similar to fracs, I know in fracs you've been seeing that they've been comparing everything to one whole. And I've been talking about wholes a lot in class as well, right? So whole as in W-H-O-L-E, meaning the entire piece. So these are two wholes, or 2 over 1, two ones, right? So if I ever want to write a whole number as a fraction, so if I want to write 3 as a fraction, I just write the denominator as 1. Now this 3 is the same thing. 3 is a whole number and 3 is a fraction. 3 and 3 wholes. So I'm explaining that because we're going to be using that in today's lesson. Let's look at this example here. Label the following models as fractions inside the boxes. I see one triangle represents one whole. And I see these triangles, so there's two wholes, and each of these wholes has been split in half. So this is 1/2, 1/2, 1/2, 1/2. So I have 1/2, 2/2, 3/2, 4/2. Oh, so this is 4 halves. I want to try this one now. And this is where I'm going to need to remember what I learned about how to write a whole number as a fraction. So again, each triangle is one whole. And I see I have one whole, 2 wholes, 3 wholes, 4 wholes, and none of them have been broken apart. So that means they're all just one whole, no fractional amount. So if I'm writing 4 wholes as a fraction, I have to write the number 1 under it. So this is 4 wholes. How about you try one now? What fraction does this triangle represent? Remember, the entire triangle is one whole. Look at the parts inside of this triangle. What fraction does this represent? So I see I have 4 equal parts, 1, 2, 3, 4. So that means they're each fourths. And they're all shaded in, so 1/4, 2/4, 3/4, and 4/4. So this fraction is 4/4. I hope that's what you thought. If you didn't, look back at what I just did. What mistake did you make, or what part was confusing to you? Hopefully it makes more sense now that I've explained it. So go ahead and try this one. Now, same idea, except now the whole is a circle. What fraction is this here? If you don't have an answer, please pause. And when you're ready, press play to check your work. So again, I see each whole has been split into 4 pieces. So they're not eighths. Even though I see 8 pieces, they're not eighths because I remember each circle is one whole. So this is 1/4, 1/4, 1/4, because they each represent 1 out of 4 pieces within the whole. So that means these are also fourths. So how many fourths have been shaded in all together? 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. So this represents 8/4, which is equal to 2 wholes because 8 divided by 4 is 2. So 8/4 and 2 wholes, or equal to 2 wholes. We're going to try this last one. And pause now and press play when you're ready. Again, pause now, press play when you're ready to check your work. All right, again, my circle represents 1 whole. I see 1, 2, 3, 4, 5, 6, 7, 8 wholes. They have not been broken apart into smaller parts or any fractional units. So it's literally 8 wholes, 8 over 1, or 8 ones, you can say as well. Now, how would I represent this on a number line? So it says fill in the missing whole numbers in the boxes below the number line. Below. Rename the wholes as fractions in the boxes above the number line. So I see we're counting by 2s, 0, 2, 4, 6, 8, 10, 12, right? So I already know my missing numbers on here. And I want to use the same information that I learned earlier about how to write a fraction and whole number as a fraction to fill in these top ones. So notice my numerators are all ones, right? For example, 2 as a whole number as a fraction is written as 2 over 1. So the same thing is true for 0, 0 over 1. No wholes, right? What about 4 as a whole? How would I write that? 4 over 1. So what would the next number be? If we continue this pattern of 0, 2, 4, what's our next number? Our whole number, and that whole number as a fraction. What would it be? So the whole number is 6, and the whole number as a fraction is 6 ones, or 6 wholes. So I want you to pause now, try these last two. What would the missing whole number be here, and what would 12 as a fraction be written? So pause now, solve those last two, then press play when you're ready. Again, pause now, press play when you're ready to check your work. Right, so 10 wholes as a whole number is 10, or if I continue this pattern, 6, 8, 10, 12. And also 12 as a fraction would be 12 wholes. So in school, you have similar problems where you either have to identify the fraction in the diagram or in the model, and another problem where you'll have to find the missing either whole number or missing fraction that should be placed on the number line. As always, you can reach out to me on Schoology or Hangouts if you have any questions. Thank you. Bye.